Welcome to Func Prog Sweden 4. Finally, we're both live on YouTube and we have a live audience. Yes, finally. We're super happy to finally be doing this. Yep, my name is Magnus. Maybe some of you know me, some of you might not know me. After this night, hopefully more people will know me. I hope so. The agenda for today, I will do an introduction, short introduction. Then we will go to functional thinking is solid and clean by Juan. And then we'll have a presentation, The Power of Functional Composition in Swift by Reda. And in the end, I'll do a short schedule and summary. First up, I would really like to thank Volvo for sponsoring both with the venue and with the food, and also with the live streaming. So thank you very much, Volvo. Really appreciate it. I reached out to Volvo and asked if they can do a presentation, and they returned and said, well, maybe, but we can support you with the venue if you like. So thank you very much, Volvo. Yes. Also, if you want to support the meetup, of course you want to do that, join the meetup group. Join and follow us on the YouTube channel. And if you're really a fan, you get a t-shirt that you can find on this Func Prog Sweden myspreadshop.net. Yes, it's a lovely gift. I've given it to my wife. That's how much she likes it. If you have questions during the presentation, online, please use the YouTube chat and I will read the questions to the presenters. If you're here in the audience and you have a question to the presenter, I will send out the mic, otherwise the people online will not hear you. Or the presenter can read back the question. Yeah? Kind of easy. So, with that, let's get started. First presentation. Functional thinking is solid. By Juan. Welcome.
Thank you.
Now we'll do the magic switch.
Yes. Yeah. I want to start by thanking Volvo again for this opportunity. I'm actually I should disclose that I work for Volvo. So I want to highlight a bit what Volvo is doing lately, what type of transformation we are doing, from being a car manufacturer to being more software-oriented company and building the services around the car. So within that context, in Volvo, we have some big bets. The first one is that Volvo wants to go fully electric by 2030. We want to be a climate neutral company by 2040, meaning that every car, everything that we produce has zero carbon emission. We are in-housing pretty much all the software development. And for this, we are, maybe you have read on some posts that we are starting a hub here in Stockholm, where we are expecting to have around 700 positions, mostly on technology and software engineering. And as well, one of the goals is to go fully online sales. A big change on Volvo mentality was to be more focused on the relationship that Volvo has with the customer and try to offer the whole journey, not just the car, right? So within that, we are as well worldwide. We have offices in China, US, some in Spain, some in India. There are a lot of jobs, a lot of open positions that we are trying to cover. You are welcome to visit and learn more about this. And after doing a bit of publicity, let's go to the functional thinking is solid. The idea of this talk is not to dig deep in details about functional programming. It's not to teach functional programming either, but mostly to see how some functional concepts, when we apply it on our day-by-day work, even if we are developing on object-oriented languages and within a pseudo-object-oriented architecture, they can guide us and make our code clean and solid, which is the principles maybe broadly adopted by object-oriented programmers to define what means clean and readable code, right? So before jumping into it, who am I? I'm Juan Chiaradia. I'm working for Volvo since the last 4 years. Currently, I'm a staff engineer. My background is on Android development. I've been doing Android development for the last 10 years-ish, pretty much since the first Android was out. I'm coming from Argentina. You can notice my perfect English. And back in Argentina, I used to teach functional programming in university, some courses. Yeah, I'm not so active on my social media, but it's there. So yeah, that's me. Now we can finally jump into functional programming and what everyone likes. So yeah, the first, or the topic of the talk was functional thinking is solid, or applying functional thinking into your solutions will lead to solid code base. So what is functional thinking? We could say functional thinking is a process applied to solve a problem in a functional way. Yeah, but that doesn't say much, right? Defining functional thinking using functional, even when it's recursive, which is a functional concept, doesn't help. So let's go one step behind and try to define functional programming. Like every good software engineer, we go to Wikipedia and we find the definition. Functional programming is a programming paradigm where programs are constructed by applying and composing functions. Not only that, but it is a declarative programming paradigm, and in which function definitions are trees of expressions that map values to other values, and they do not, or try not to, change the running state, right? So here we can identify application and composition of functions, declaring expressions that map values to values, and avoid side effects or avoid changing the state, right? So yeah, apply and compose functions, work with declarative expressions, avoid side effects. If we apply this concept, we could say that somehow we are applying functional thinking. Pretty straightforward, right? But what does that really mean on our code base, right? How do we apply this to our solutions, right? So let's start for the first part. What does it mean to compose functions to solve a problem by composing functions? So mathematical definition of functional functional composition is basically to use the input, the output of one function as the input to the other function, compose both together in a higher abstract function, and get the expected output, right? That's okay, right? But again, what does it mean on the code base? Do we apply that on our code day by day? So do you want to see an example of it? Yeah, okay. Let's take, for example, our application, right? We have a UI that shows what is the current state of your car. It shows a snapshot of the car. The car is locked, not, the door is open, if the climatization internal is running, and many other aspects of the car, even the windows and other stuff, right? How do we build this snapshot? We get it from the screen data, right? That we compose or we apply, we map to whatever we show on the screen. On its own, this screen data is built on application level or domain level data, but on its own is built from cloud data that is getting it from the car on the last instance, right? This is not something new. This is quite common on pretty much every cloud-based application out there, right? So we have a clear composition where we have our JSON or representation of the car state from the cloud that we usually map into a domain object that makes sense on our domain layer, that finally we will map on the screen representation of that domain layer that will be shown on the screen. So we can say that for building a car UI for a given car ID, we get the car snapshot that is built from the car state, that is built from the cloud car state composition, right? So this is still talking about functions somehow, right? What does it mean now if we jump to a specific Kotlin code, Android code? Well, usually the mobile applications, they follow a similar architecture than this, with maybe different flavors, where we have a view model that will control our UI, and both together define the presentation layer. We'll have a repository or equivalent that will define the domain layer together with the entities. And we will have a API, cloud API, could be a database or a data store that will define the source of the data, right? So if we apply the composition thinking pattern here, what will allow us to do is to start decomposing the whole journey, the whole problem, into step by step. We can start, for example, by the more visual feedback, which is the UI. We can try and build a car view that only receives a car snapshot, that we can mock. We can create our struct if you are using Swift, or our data class in Kotlin. And we can focus only on the part that, given a car snapshot, we need to show the corresponding car on the UI, right? Once we manage to do that, we can move to the next step, which will be to create that car snapshot, right? On our view model, we could either, again, mock a repository or mock the whole car state together, and we can focus on the map to a car snapshot function. Then once we have the view model providing the car snapshot, we can link together our UI with the view model and make the UI listen to the changes on the view model or update itself whenever the view model changes, right? And finally, we can go to the lower step where on the repository implementation, we can focus on how to map the JSON data into the entity, the domain entity that we are going to work around the application. Yeah, so that's if we resume, we have on the presentation layer, we have the view model that gives us the snapshot that is built from the car state, that is built from the cloud car state. So we are applying composition on our daily basis. I'm pretty sure that if you are not functional purely programmers, and if you have been working on object-oriented similar patterns like this, you have been using, or maybe some flavors of it. And on my personal subjective opinion, it's quite straightforward what is happening on each layer, what is the responsibility of each of those, right? Bob Esponja, yeah, Bob Esponja. That's Spanish for SpongeBob. Agrees with me. So yeah, functional composition is one big topic of functional programming. Another word that was there was apply functions. And we can as well talk about partial application. What is partial application? A partial application is whenever we have a function that receives two or more arguments. And based on that low-level function, we can call it, we want to create a higher level, abstract one of these arguments, and fix that argument to a particular value. So the higher level function doesn't need to know about that argument, right? Question is then, are we using partial application on our code base? Have I used partial application on the pieces of code that I showed before? If we come back to the composition example on the functional-ish way, we only have one argument, right? So somewhere we hide arguments, or maybe we haven't used it at all. Let's see what the Kotlin code what has to say about this, right? So we say that on our UI, we are showing or presenting car snapshot, and we get this car snapshot from the view model. On the view model, we get the car state from the repository. On the repository, we get it from the cloud. Do you see the second argument on each of these steps? When we program on object-oriented, we are sending message to the object, right? The receiver of the message, if we translate the message into a function, we can say that the receiver of the message is an argument of that function, right? On this case, for building a car snapshot, we need to know about the view model that we are going to get it, right? For getting the car state, we need to know about the repository. For getting the car from the cloud, we need to know what is the cloud that we are pinging, right? Yeah, so why is this important, at least to identify? We could then I lost my pointer. Here it is. We could then rewrite our functions to each of them having the 2 arguments that they need, right? And what we are doing in real life or in our code base, now let's take the example of a repository. The way that we apply partial application is by having an implementation class that stores that partial parameter as internal state of the object, right? This is important because the arguments that we are trying to hide away from a more abstract layers are defining the dependencies of our class, right? They are defining what do we need in order to provide the abstraction that we need on the level that we are, in this case on the repository. And then we can provide a car cloud with any dependency injection framework, Hilt or Coin or any other that you prefer, right? So partial application, then what it helps us is to abstract away the implementation details. On our UI, we don't know anything about repository. We know that we have a view model and a car snapshot that we can get from that view model. How do we get it is not a concern of the UI. The same happens for the view model, doesn't know anything about the cloud. And the repository implementation doesn't know anything about the car, if we like. Yeah. So why do we want to use it? To hide implementation details, to identify dependencies, and then be able to use dependency injection to provide those dependencies that we just identified. But yeah, partial application and functional composition, they are not the only big concepts on functional programming. Many may argue that the next one is the biggest concept on functional programming, which is the existence of high order functions, right? So what is a high order function? In simple words, it's a function that can be used as a parameter or as a field. Very simple words. And why do we want high order functions? Is to be able to abstract behavior, to be able to construct or compose a function where our high order functions are argument of that function, and then be able to change the behavior of that final composition without needing to change the implementation of that composition, right? That looks nice, right? So can we apply this on our code base? If we come back to the functional-ish composition here, this is a good composition, but we are hard coding, or we are defining explicitly what are the functions that we are applying, right? So if we use high order functions, we can abstract away each of these and receive it as a parameter. And then we are able to change the behavior of our, or to extend the behavior of the car snapshot function without needing to change the composition structure per se, right? Again, how this is nice. So how do we bring it into Kotlin? If we take the view model, for example. The view model, we are using partial application to hide the repository from from the UI, right? We are using the repository to get the car state, right? So we could move all this dependency to a high order function. And then our view model doesn't need to even know about a repository. We only need to know that we need a car state, and the responsibility of the view model is to map that car state into a car snapshot. If we talk about object-oriented and clean architecture, there is a concept that we use a lot, which is a use case, usually to not only, but to model abstractions, behavior, sorry. And then we can create a class, a use case class, or an action class, if you want to call it. On Kotlin, we are allowed to use function types as a supertype. And then we can implement our behavior on this function type, right? This is still a bit of boilerplate code. Kotlin goes a step forward and allows us to directly access to the functional reference of the method of the repository. And then we are creating a class, getCarState, a use case class or an action class that is a subclass of a function by the getCarState method on the repository. So we are abstracting away not just the repository, but the whole function call. Then on our dependency injection layer, we could instantiate our view model by passing this use case. Or we could even, if we go back, here we have a functional type. We don't have a use case, right? So we could even go all the way and avoid the whole use case class and directly instantiate our view model with the car state, right? Why would we like to do this? Why having repository is not good enough? One of the principles is interface segregation, right? Which says basically we should not depend on behavior that we are not using. The repository here more likely will have more methods than a single getCarState, right? So to avoid depending on a class that may change for some other reasons that doesn't have anything to do with my personal responsibility as a view model, then we go this way, and then we can, reach that goal. Yeah, so on my eyes, at least, this is pretty nice, and it's good to have, right? So next big monster on functional programming is the side effects, or the lack of them. Or at least that's how it's misunderstood, right? Side effects or functional programming on the purest world, it means or tries to avoid side effects and apply on a mathematical way definitions of functions on top of definition of functions. But the reality is that we will always need to write something on a database or show something on the console or on the UI, right? So if we go back to our application, we have a button on our app that we receive a notification that says you forgot to lock your car. So we are far away from the car. We don't want to walk back again. We press the button to lock the car and lock it remotely, right? So that lock action will float all the way till the car. The car itself will lock, will change its state. We have a side effect there. And that new car state that is now locked will go back, and we will show it on the UI. Your car is now locked. You can enjoy your beer quietly. Yeah. Or if you drink water, you can drink water as well. Yeah. So the important thing here is that during this whole journey, both ways, in the middle, we didn't have side effects. We have side effects that happen here on the car. We built a new car state. We send it back. It went through all the steps without a state change, sorry. And then we presented on the screen with a new side effect, right? If I can open this, good. So how does this relate with the code? On our UI, we will have a lock button that tells our view model we need to lock the car. Our view model knows the car ID already, tells a repository you need to lock, or we can use the high order function, use case, action, or whatever you want to call it. And we locked. And eventually, the repository will tell our cloud that has to send a lock to the car. On all this step, the side effects happen on the last one. On the way back, whenever the lock succeeds, we publish a new car state. This new car state, or our view model, will be observing or listening on that car state, and will map that car state to a car snapshot. And as we have today on our UI, the car snapshot, we are observing on the changes on the car snapshot, and the UI will update as well itself on based on that change, right? On this way back, the side effect happens on the UI, on the last step, again, right? There is something, a big concept that I won't be able to talk today, but if you have heard of it, you may have identified here, which is reactive programming, where we have, or you use a stream of data, and then you react to the changes on that stream. So here our stream will be the car state flow. On Kotlin, we use flow. It's a library or a hierarchy of different that implement the stream. And if you have used Rx Java, or if anyone is a React programmer, you may be aware of this technique. But yeah, unfortunately, that topic is not on the scope of this presentation. I only had so limited time, unfortunately. So there is a lot of material out there to check on reactive programming. Just as a small reference on Kotlin, you will use the library flow for it. Another big topic that we touch a bit, but not so much, is about immutability, where basically you define val as your fields on Kotlin, and that will make the language not compile whenever you try to modify your val, right? Another big topic is the separation in between data and behavior, that within the object-oriented community is more and more popular. On Kotlin particularly, we can talk about data classes that doesn't have any method and is the equivalent to a struct on Swift, where we could have all its fields, immutables. And then behavior, we can build our use cases as we saw before. And the latest, not on this topic, on this topic is monadic error handling. As well, a lot of material out there. In Kotlin, already support, the language already supported, just by using result. Monadic error handling is basically, instead of throwing an exception, you return an error that is failure or success. It's kind of a maybe or a either in functional languages. Yeah, and then you can decide when to handle that error. So yeah, we presented some concepts on functional programming. We tried to see how they reflected on the code base that we built following them. But the title of the talk was about functional thinking is solid. So what is solid, and how does all this relate to solid? Solid is 5 principles on object-oriented for the ones that haven't heard about it. And it stands for single responsibility principle, which says pretty much an object or a class should only change for one and only one reason. Another way, it should have only one responsibility. So how the functional thinking help us into reaching that single responsibility? As we saw before, the compositional nature and the compositional approach of our solution allow us to focus on one step at a time, solving one problem at a time, on one level of abstraction at a time, right? So that will help us reaching that one thing at a time will be the one responsibility that on that level of abstraction we will be using. The function definition is input, output. Give me an input, I give you an output. You cannot not add more responsibility than that. It's a single responsibility by definition, right? Then when we talk about side effects, because that's the mathematical definition of a function, but then when we will go to code, we can give you an input, we can, from an input, we can build an output and give it back, but we do something on the back, right? And that's the side effect that we want to avoid. That's why it's quite important to be totally mindful and conscious about when our code base is doing side effects, and try to scope it as much as possible, and try to follow a rule that a function, a method, either calculates a value from its input or generates a side effect, but not both. When we do both, we start complicating stuff, and funny bugs start happening around the code base. So if we go to, again, the original code base, we have our UI. That responsibility is to grab the car snapshot and present it to the UI. The view model, the responsibility is to build a car snapshot from a car state. And the repository will be publishing or emitting the car states that builds from the cloud. One responsibility on each. The O from solid comes from open-close principle. Software entities classes, functions, objects, modules should be open for extension, but closed for modification. What does it mean? That whenever you build your piece of code or your piece of software, bless you, you want to be able to extend that piece of software because the problems changes or your application has new requirements or something happened in the way, you want to add functionality, right? But while adding that functionality, you want to do not change the functionality that is already existing and working well and that you don't need to change, right? And this principle is mostly focused on the code base, right? So if you write your code on a way that you can add new behavior without touching the existing source files or source code that was before, then you can ensure that you are adding new functionality and that you are not introducing regression bugs because the code that was there, you never touch it, right? So how do we get this principle with a functional approach? By abstracting away our use case on the view model, for example, and let's say that the car state, instead of from the repository, we want to get it from a database, or we have a cache, or we have something else, right? We can just change the implementation of the function that we give here. And then we are changing the behavior of view model without changing actually the code that is written for the view model, right? So the high order functions or use cases or actions, together with dependency injection, we need to be able to tell what implementation of the function the view model is using at the time, right? Will allow us to extend without modifying, right? In object-oriented, we use interfaces a lot for this. And a function is an interface that we bring to the limit of single responsibility, right? Another big technique for ensuring this principle that unfortunately wasn't covered is using reactive programming plus immutability, right? The reactive programming, you have one stream and you can observe on that stream and react to it. So if, for example, let's say we have analytics, we send an event and we publish an event on the stream. Today we send those analytics to Google Analytics. Tomorrow we want to add Firebase. The way that we send those analytics to Google Analytics was by listening or observing on the reactive stream and then reacting by sending that. From a different piece of code, we can observe on the same stream and then react by sending to Firebase without touching all the previous existing code, right? List code substitution. This is the L of solid. So what this basically says is that if we are replacing an object or a parameter, an argument, with a subtype of that class, the piece of software should work as expected. We shouldn't break it, right? So what we are saying here is that no matter what application implementation of get car state we send, view model should still work within its behavior, right? So basically, avoid side effects to avoid unexpected outcomes. or be aware of the side effects that you're introducing on your code. That will be a better wording, right? We could use the monadic error handling. I don't know if you paid attention here, to encapsulate the exceptional cases. Then the behavior of get car state is always the same, success or failure, but it doesn't crash because of unexpected exception, right? And we need immutability mostly to help with the side effects, and as well if we are using reactive programming. Interface segregation. So what this principle says, we talk a bit about it, is that your class shouldn't have an extra dependency that is not using, right? That is not needed. The reason for this is that if we change something on the repository, we shouldn't need to recompile this class. We shouldn't need to, a change that is not impacting the explicit use of the repository on the view model shouldn't impact the view model, right? So to avoid that is that we use a higher order functions to bring to add each dependency that we need from the view model. And finally, dependency inversion. The goal of this principle is mostly to avoid recompilation. The principle says that your code base should depend on abstractions and not on concrete implementations. The background for this principle is that the concrete implementations are likely to change, while the abstractions, if they are good abstractions, they may or should keep stable. If we separate both things, whenever we change something on the concrete implementation, there will be a recompilation need, but the modules or pieces of code that depend on your abstraction, they won't need to recompile because you are still depending on the abstraction that hasn't changed, right? So we get this by the higher order functions as well. We use the higher order function as our abstraction. The from string to car state is the highest abstraction ever that we can use. And this will never change. So our presentation layer is consuming this, the view model is consuming this abstraction, right? It's invoking it and doing something with the result, but doesn't know anything about what is the particular implementation of that abstraction. Then the data layer, the implementation of the repository, is the one that actually gives the specific implementation for it, right? And all the way, the higher definition, which is a type, will be agnostic. It doesn't know anything about who is using it or who is implementing it. It is just is, right? It exists. Yeah. So with this, I hopefully cover the 5 solid principles. And hopefully I haven't confused you enough. Or maybe I confused you enough so you go and do your own research after this. And let me just end up with some close notes. Object-oriented and functional programming. Back in the days when I was in university, it was kind of a fight in between. what object-oriented is better, applies better to the real world, or functional programming is purer, is mathematics. Mathematics is the bigger through. But nowadays, we see that most of the languages allow functional programming techniques, at least, right, or capabilities. And basically, you don't have to do either or, right? You can apply object-oriented to the portions of your code or of your solution that makes sense and is more natural for object-oriented. You can apply functional programming to the other part, right? And you can combine both and get the best of both worlds, right? If you are purely object-oriented, you don't need to go all the way functional programming. You can apply it only on the places that you need it, and you can start with the small parts of your code. Maybe you end up liking it, right? It can take some practice. It's not automatic. Mostly if during your whole professional career you've been taught and used to think in objects or in classes and hierarchies, right? But once you master it and you get used to it, at least in my personal experience, it has helped me a lot to structure my line of thinking and keep a common routine, right? One final note is that there is a SpongeBob GIF for everything. Yeah. Yes. Hopefully, if one thing you got from the talk, you either love or hate SpongeBob today. Yeah. So yeah. Any questions? Thank you.
There you go.
Yeah, let's see. Is it working? Hope so. So yeah, you made an interesting point of basically looking at different functional programming concepts and the solid principles and kind of seeing them as one and the same in some ways, a different way of looking at the same thing, or I should say FP and object-oriented concepts.
Yeah.
But I want to ask, in one of the examples you gave, it felt like there was a contradiction between them, and maybe I missed something. When you were talking about, so first you had this hiding that one parameter, so partially applied functions.
Yes.
And you put the repository in as the hidden parameter that
Yes.
carries over. And later you showed an example where you were doing, what was the later one? It's hard without everything in front of
On
your
the
head.
cloud. That
Sorry?
the repository goes to the cloud.
No, well, later you were doing the, you got the higher order function
Yes.
and took the get car snapshot from repository, made the assumption that it's a static function, and basically was able to pass that as a function to a higher order function.
Yes.
My question is, when you did that, you lost the repository as a partially applied parameter, and you can no longer depend on the repository as a data, as an object.
Yeah. We went even one level higher of abstraction. We not only hide the repository from the UI, now we hide it even from the view model.
Well, no, you don't hide it. You prove that you never needed it.
Yeah.
So why did you put it in why did you need to pass it in as a partially applied thing from the beginning?
Because at some point you will need to access to that repository or to the cloud unless you go functional all the way, right?
Yeah. So, but then your second example can't be possible because you're directly connecting to that get snapshot function without having a repository object.
Yeah, but the one that is partially applying the repository is the dependency injection layer when we instantiate the view model by sending the repository or the use case that implements that class. Let me see if I can exit the, okay. Let's try to find it out. So I think that it was this
Right,
slide
so
too.
here.
So yeah, we move this one away, right? And then we remove the need of a repository from the view model, right? But at some point, someone needs to implement this function, right? And this function still receives one string, the car ID, and gives back a car state. But the way that you implemented, you need to go through the repository to be able to get that car state. And here is where the partial application happens. You either hide it on the use case implementation, or you hide it on the dependency injection layer when you send it here.
So maybe I'm not familiar with Kotlin syntax here, because to me that looked like giving a pointer to a static function.
No.
Get car state
Yeah,
from the repository.
exactly.
And
Maybe
saying,
that's your confusion. This is an object, right? I wasn't totally clear here by saying on the dependency injection layer, you will get the repository from the dependency injection, right? Because you need a repository. And then this is a pointer to the function of that object, of that repository.
Okay, then that makes more sense. Thanks.
Okay, yeah, don't worry.
I'll turn it off. Is there any more questions? Oh, yeah, one in the back. I'll run.
Yeah, thank you for your presentation. Do you use Kotlin on the server side at Volvo or only for mobile development?
That's a complicated answer. Some servers use Kotlin, some use other technologies. Yeah, most of them don't. But yeah.
So is there any kind of movement or activity of like moving some older implementation from Java over to Kotlin or some stuff like that?
There are some initiatives within Volvo. The technologies on the server side is, let's say that we have way too many different servers. And we are using C# for some of the stack. We are using Java for some of the stack. And yeah, Kotlin is something that is interoperable with Java. So there have been some proof of concept with the Kotlin, but there is already expertise on the other technologies.
Got it. Thank you.
Yeah.
No? Thank you very much, Juan.
Thank you.
Thank you very much. Yeah, please disconnect that. And we'll get our next presenter up, Reda. And take your time and go and grab some pizza or some beverages while we connect this laptop.